Hey everyone, here's a quick way to sketch a graph of y equals tangent 4x. So we have the general form of a basic tangent equation and an outline of steps to follow. Start with step 1, find the essentials. A is your leading coefficient in front of tangent. We don't see anything in front of ours, so we understand there's a 1 there. Okay, that's going to be our vertical stretch factor. It's going to help us with the y coordinates of our curve setting points. So these two in our key points pattern of step 2. So we'll come back to that very soon. Okay, B is the coefficient in front of x. For our equation, it's 4. And this is going to help us calculate the period or the horizontal length of one cycle. The formula is super easy. Just make sure you use pi divided by b for tangent. Okay, so our period is pi divided by 4. And as soon as you find that, go ahead and divide that by 4. Okay, so we'll do it and then talk about it. Pi over 4 divided by 4, same thing as multiplying by 1/4. Okay, we're going to use that value that we get, 1 pi over 16, as our horizontal scale. Basically, we took the period, we divided it into 4 pieces, and those 4 pieces are going to be our 4 key points in step 2. So these points will line up nicely with our horizontal tick marks. You don't have to do it this way, but it sure does make it so much easier. All right, so let's go ahead and label our axes. We're going to do just one cycle here first, and we're going to do 4 tick marks, counting by 1 pi over 16. So we have 1 pi over 16, 2 pi over 16 is pi over 8, 3 pi over 16, 4 pi over 16 is pi over 4. And this 4th tick mark to the right will always match your period when you set it up like this. For the vertical axis, we're just going to use 1, so up 1 and down 1, and that goes back to the value for A that's going to help us shape our tangent curves. It's the vertical stretch factor. So just up to 1, down to 1, that will cover us. All right, now we're all set up and we're ready to plot our key points pattern. So for a basic tangent graph, remember this is 0 starting at the origin, so an x-intercept on the origin, your upper curve shaping point, your vertical asymptote, and then your lower curve shaping point. All right, so start with your 0 at the origin, move to pi over 16, and you're going to get the y coordinate by looking at your value for A, so 1. Okay, that will help us shape our tangent curve. Then our pi over 8 is going to be our vertical asymptote. And at 3 pi over 16, we'll have that lower curve shaping point. So 3 pi over 16 and the y coordinate is just the opposite value of A, so -1. And then you'd repeat your pattern starting at pi over 4. So step 3, let's sketch in one cycle of tangent. I like to call this a broken cycle of tangent just because it has the asymptote in the middle. If you'd like, you can sketch out a few more cycles just so you can see everything, the full unbroken cycles of tangent. Okay, but you don't have to do this. This is just to show you that you can have as many cycles of tangent of 4x as you'd like. All right, the last thing is a really helpful tip on finding the equation of the asymptotes for this graph. So all you have to do this is take your horizontal transformations or your inputs of your tangent function, so 4x, and set that equal to the original equation for your asymptotes of tangent x. So those are at pi over 2 plus pi k, where k is an integer. And we're going to solve for x. Basically, we're applying these horizontal transformations to those original asymptotes in order to get the asymptotes for our graph. So very easy, divide everything by 4 or multiply by 1/4, whichever you like. And our asymptotes equation for our graph is x equals pi over 8 plus pi over 4k, where k is our integer. So if you substitute in 0 for k, it's really easy to see, yes, we have our asymptote in the right place of our graph. When k equals 0, we have an asymptote at x equals pi over 8. If you wanted to sub in -1 for k, practice that on your own, but you'll get this asymptote to the left, the one in green, at x equals -pi over 8. So sub in values, once you're used to working with this equation, it's actually very easy and very useful in finding particular asymptotes for your graph. So that's all there is to it, a really quick and easy method for sketching a basic tangent graph, and a way to find all the asymptotes as well. Be sure to subscribe for more examples and lots of other great tips.